all. Today we start with Module 1, Chapter 9, Vector Calculus of the text Advanced Engineering Mathematics by Dennis G. Zill. We are moving on to section 9.1, Vector Functions. So before defining vector functions, we will discuss something about parametric curves. Suppose we have a function with single input t. Its output is a vector. That means output is two-dimensional, input is one-dimensional, and the vector is depending on t. And the vector has polar components. Vector has polar components. The x component will be t cos t and y component will be t sin t. This is what is called a parametric function. So we will call this a parametric function in one parameter, and the parameter means here some variable to input or some input. So we have input in one dimensional and output in two dimensional. Okay, now we will move on to space curve or parametric curve in a space. A parametric curve in a space or a space curve is a set of ordered triples x, y, z, where x is a function of t, y is another function of t, and z is yet another function of t. So here it is given x is f of t, y is g of t, and z is h of t. These functions are all continuous on the interval a, closed interval ab. This closed interval ab we can write as a less than or equal to t less than or equal to b. Okay, like that also we can write. The two-dimensional parametric curve is a set of ordered pair xy where x is f of t, y is g of t. Here there is no set here, so we have no set function here, where same g and f are continuous functions on closed interval ab. So we can now define vector functions. So what is a vector valued function? Vector valued functions are vectors with functions as their components. Once again, vector valued functions are vectors with functions as their components. These component functions are functions of a parameter t. We say that r of t is ordered pair f of t, g of t, or we can write as f of t I plus g of t j. Again in 3 dimension, r of t is f of t, g of t, h of t. That is also same as f of t I plus g of t j plus h of t k are vector valued functions or simply vector functions. Here I, j, k are unit normal vectors in x coordinate, y coordinate and z coordinate respectively. Okay, now so we know what is a vector valued function. If it is given it is in 2 dimension, this is the formula for vector valued function. If it is given in 3 dimension, this is the 3-dimensional formula for vector valued function. Okay, so it is very easy because we have first coordinate, second coordinate, third coordinate. So first coordinate will go to I, that is x coordinate, second coordinate goes to j, y coordinate, and third coordinate goes to k, z coordinate. Okay, so we can remember it easily. Now we will move on to sketching the graph of a function, vector valued function. So if we are given a vector valued function, how we can sketch the graph of that function? It is very interesting. So here we are given a vector valued function. Okay, that is given as r of t is equal to ti plus t plus 2j. So t is a function of t, then t plus 2 is a function of t. So here f of t is t and g of t is t plus 2. So we can write x is equal to t, f of t, x is equal to f of t, like that now. so f is equal to t. Then g is equal to t plus 2, so y is equal to t plus 2. Now what we have to do is we have to eliminate t from these two equations. In order to eliminate t, what I am going to do in this equation, I am substituting this equation. That means in the place of t I will put x here, so I will get y is equal to x plus 2. Okay, now I got 2 points, that is 0 2 plus t into r. T is equal to 0 2 into plus t into 1 1. Now I have to plot the curve. So this is when to plot the curve we will put t is equal to 0. Then t is equal to 0 means what we'll get, or we can plot this line, no, this line we can plot. So here we will plot xy. X is equal to 0 means y is equal to 2, then y is equal to 0 means x is equal to minus 2. So here the curve is a line. So what we learn from this, what we are doing is we are making vectors, and the arrowheads of the vectors will determine the curve. So here the arrowhead was here, then it was here, then it was here. So how the arrowhead will go, that curve will be getting as the sketching of the parameterized curve function. Okay, now we will do one thing. So here we have a remark here. For a given value of the parameter, say t naught, the vector r of t naught is the position vector of a point P, on a curve C. When the parameter t varies, the arrowhead of the changing vectors traces a curve C, and that C is the space curve. So we will see this example in the textbook. I have uploaded the textbook in Google Classroom, so you can have the textbook here. So here you look, here we have the arrowhead. So as the arrowhead varies, we will get a curve here. So it is the head of the arrow that determines the curve. So each vector, at each t we are getting a vector r of t. As t varies, we are getting many vectors, and all the arrowheads of that vectors will determine the curve. That is the thing. Okay, now we will go for the example. These all things we have looked on. Now we will move on to example, another example, that is example 1, circular helix. Okay, so we have the graph, the curve traced by the vector function r of t is equal to 2 cos t I plus 2 sin t j plus tk where t greater than or equal to 0. This is the question. So from this we can easily find x is 2 cos t, y is 2 sin t, and z is t. Now what we have to do? We have to eliminate t from these equations. We already know that cos square theta plus sin square theta is equal to 1. So here we have cos theta and here we have sin theta. So what we will do? We will square x square plus y square is 2 cos t whole square plus 2 sin t whole square, that is 2 square into cos square t plus sin square t. This portion is 1, so we get 4. So what we got? We don't have t now in this equation. We have the equation x square plus y square is equal to 4. Then we have z is equal to t. So we have the z axis itself. So what we get is a circular cylinder, and the points of the arrowheads will determine a helix. Then the points, how we will look points? We will have the pi by 2, 0, pi by 2, pi, 3 pi by 2, like that. We will vary the values of t. Then we will get the values of x, y and z from this equation. Then according to that we will plot the helix. I have plotted the helix like this. In textbook we can have a little bit nice notation of the helix. Here it is the notation. So we have these points. Okay, we have when t is equal to 0, then x is 2, so this is the point. Then we will move on like this. Okay, then we will get a helix, circular helix. So that is about example 1. Now we will pass on to example 2. Example 2, we have in elliptical cycle. Okay, this is our now here a remark we have. The curve in example 1 is a special case of vector function, that is r of t is a cos t plus b sin t j plus c t k, where a b c greater than 0, which describes an elliptical helix. If a equal to b, the helix is circular and the pitch of the helix is determined by 2 pi c. Okay, so we will have now we will look at example 2, that is circle in a plane. So graph the curve traced by the vector function r of t is equal to 2 cos t plus 2 sin t j plus 3k. In the previous equation there was 3t here now there is no t, this is a constant. So the parametric equations are x is 2 cos t, y is 2 sin t, z is 3. Okay, so we have cos t and sin t here, so we will make use of the identity. So x square plus y square is equal to 4. So we got x square plus y square is equal to 4. There is no t here, already z is a constant, so this is the eliminated form. Now we have to plot this. So z is a constant, so it will be parallel to the xy plane. Then this x square plus y square is equal to 4 is a circle. Since the z coordinate is a constant, the vector function r of t traces out a circle of 3 units above the xy plane. That is the figure. This is the figure. If you want a clear figure, I can show you the textbook here. So you have this figure. Look at this figure. Here the arrowheads, the motion of the arrowheads determine the curve, red curve. So each arrowhead is a vector. As t varies, we will get more and more vectors. Then all the arrowheads will determine the cycle. അതായത് വെക്ടറിൻ്റെ ഏരോ ഉള്ള ഭാഗം കുറേ വെക്ടേഴ്സ് നമുക്ക് കിട്ടും. ആ വെക്ടേഴ്സിൻ്റെയൊക്കെ ഏരോകൾ ജോയിൻ ചെയ്താൽ നമുക്കിങ്ങനെ 3 സെൻറ്റിമീറ്റർ സെഡ് ആക്സിസിൽ ഉയർന്നു നിൽക്കുന്ന ഒരു സർക്കിളാണ് നമുക്ക് കിട്ടുന്നത്. അതാണ് നമുക്ക് ഈ പിക്ചർ കണ്ടാൽ നമുക്ക് മനസ്സിലാവുന്നത്. ഓക്കെ, ദെൻ ഇനി എക്സാമ്പിൾ 3, curve of intersection. Find the vector function that describes the curve c of intersection of the plane y is equal to 2x and the paraboloid z is equal to 9 minus x square minus y square. Okay, so in previous cases അവരെന്താ തന്നെ നമുക്ക് ടിയിലുള്ള പാരാമെട്രിക് ഇക്വേഷൻ തന്നിട്ട് കർവ് ട്രേസ് ചെയ്യാൻ പറഞ്ഞു. ഇപ്പോൾ നമുക്ക് എന്താ തന്നിരിക്കുന്നത്, ഇപ്പോൾ നമുക്ക് എക്സ് വൈ സെഡിലുള്ള ഒരു ഇക്വേഷൻ തന്നിട്ട് നമുക്കതിൻ്റെ പാരാമെട്രിക് ഇക്വേഷൻ കണ്ടുപിടിക്കാനാണ് പറഞ്ഞിരിക്കുന്നത്. ഓക്കെ, സോ വി ഫസ്റ്റ് പാരാമെട്രൈസ് ദ കർവ് സി ഓഫ് ഇൻ്റർസെക്ഷൻ ബൈ ലെറ്റിംഗ് എക്സ് ഇസ് ഈക്വൽ ടു ടി. അപ്പോൾ നമുക്കൊന്നുമില്ല, പേടിക്കാനൊന്നുമില്ല. നമ്മൾ ആദ്യം എന്ത് കൊടുക്കണം, എക്സ് ഇസ് ഈക്വൽ ടു ടി കൊടുക്കാം. അപ്പോൾ നമുക്ക് എക്സ് ഇസ് ഈക്വൽ ടു 2t കൊടുത്താൽ വൈ ഇസ് ഈക്വൽ ടു എന്ത് കിട്ടി, 2t കിട്ടി. ആ രണ്ട് വാല്യൂ ഈ ഇക്വേഷനിൽ കൊടുക്കാം. അപ്പോൾ നമുക്ക് എന്ത് കിട്ടും, z ഇസ് ഈക്വൽ ടു 9 മൈനസ് ടി സ്ക്വയർ മൈനസ് 2t ഹോൾ സ്ക്വയർ. So z is equal to 9 minus 5t square. So we get all the parametric equations needed, that is x is equal to t, y is equal to 2t and z is equal to 9 minus 5t square. So we can easily write the vector function. So the vector function is what? The vector function is rt is equal to x inde idu ivide ezhudha, I inde avade ezhudha, ti വൈയുടെ 2t, ജെയുടെ അവിടെ എഴുതാം 2tj, സെഡിൻ്റെ വാല്യൂ ഇവിടെ കെക്ക് എഴുതാം 9 മൈനസ് 5t². ഐ ജെ കെ എന്ന് പറയുന്നത് നമുക്ക് ഇങ്ങനെ ഒരു യൂണിറ്റ് വെക്ടേഴ്സാണ്. ഐ എന്ന് പറയുന്നത് എക്സ് ആക്സിസിലും ജെ എന്ന് പറയുന്നത് വൈ ആക്സിസിലും സെഡ് അപ്പുറത്തേക്ക് കെ എന്ന് പറയുന്നത് സെഡ് ആക്സിസിലും വരുന്ന തരത്തിലുള്ള യൂണിറ്റ് വെക്ടേഴ്സാണ്, നോർമൽ വെക്ടേഴ്സ് പെർപെൻഡിക്കുലർ ടു ഈച്ച് അതർ. ഇനിയിപ്പം ഇതിൻ്റെ ഫിഗർ എന്ന് പറയുന്നത് ഇങ്ങനെയാണ് വരുന്നത്. ടെക്സ്റ്റ് ബുക്കിൽ വേണമെങ്കിൽ കുറച്ചും കൂടെ ക്ലാരിഫൈഡ് ആയിട്ട് നമുക്ക് കാണാം. So here we have the set is 9 minus x square minus y square. This is the curve. Then we have the circle x square plus y square is equal to 9. Then this will be the graph of the function. Okay, so now we have studied about vector valued functions and all. In next class we will study about the limits, derivative, etc. of these vector valued functions. Thank you for listening.